As I mentioned in the previous video, I said I would do the derivation of the angle formula, which is totally optional. So what I want to start off with is giving you one quick fact about, or actually a couple quick facts about dot product that we'll use. The first one is pretty easy to show. If you look at the formula for magnitude of a vector, it's the square root of its first component, its x component plus its y component squared. So if you square that, you actually end up with just u1 times u1 plus u2 times u2. And this is actually the same thing as u dot u. So that's something that we'll need. And then the other thing I want to mention is if I have u plus v dotted with, say, u plus v, the dot product does kind of work out the same way as regular binomial multiplication. So this equals that. Okay, so we're going to use these two facts in this derivation. All right, going back to the angle in between two vectors. Let's say I have an angle or a vector here, u, and let's say I have another one here, which I'll call v. I'm interested in this angle. Now what we're going to do is actually create a triangle here. Oops. So I'm going to go ahead and connect these 2 points and make that a triangle. So the question is, what is this side? And you can get this if you think about, let's kind of resketch this over here. If you think about what addition of vectors means, let's say I have my u. If I add a vector to u, I would end up here. So whatever vector this is my question mark vector basically, I would end up there, which would be v. So the question is, well, what is that vector? And we can kind of do this just by construction. If I add the vector, whatever v minus u is, notice that the u's cancel out, and I'm just left with v, because u minus u would just be the 0 vector. So I'd just be left with v. So by construction, this vector is actually v minus u. Now in order to find this angle, we're going to use the law of cosines. Law of cosine says that cosine of theta equals the length of this side, which we could just call the magnitude of u, and then this side as well, which would be the magnitude of v. So that's squared minus this side here. So if you take a look at our law of cosines, it's a squared plus b squared minus c squared. So the length of that side is just the magnitude of a vector, so then I square it and I end up with that. And then in the denominator, it's divided by 2 times a times b. Well, that's just the magnitude of u times the magnitude of v. Okay, so it looks pretty awful right now, but let's go ahead and use the first fact, which is u dot u equals the magnitude, and then v dot v equals the magnitude of v. And then this over here is going to be v minus u dotted with v minus u. And then all of that, I'll leave that as magnitude for now because the final formula does actually have magnitude in it. So I'll leave it like that. Okay, so this part here, this is just going to be v dot v minus 2u dot v plus u dot u using binomial multiplication. We distribute the v to the v and then v to the negative u, etc. But all of that has this minus sign out front. So what I end up with is u dot u plus v dot v. But then it's minus v dot v, so those are going to cancel. And then minus turns into a plus 2u dot v, and then minus u dot u. So notice that the u dot u and that will cancel out, the v's will cancel it there, and I'll be left with this term right here. And then all of that will be over this. Now we're actually about done. This cleans things up really nicely. So at this point, the 2 divided by 2 is just 1, and so I'm actually left with a formula cosine of theta equals the dot product of u and v divided by their magnitude product, which is the formula that we actually wanted to prove. So there you go. There is the optional derivation